I am just thrilled to be here today to tell you about what we're up to in Boulder, Colorado at Frustum Inc. I brought my good friend and colleague, Kevin Schofield, our VP of Marketing. What we're hoping to do here is talk a bit about our position and why we're doing what we're doing, what we believe we're doing, how it's different, and how it's going to impact the future of design. We're going to be showing some live demos too, so I'll try to be fast with my slides, and then I'll turn it over to Kevin, and he can use the product for you. So what we're up to right now is launching a new version of Generate. So a lot of you know Generate has been a web app for some time, but today we're going to show you the Windows version of it, and I'm going to describe why we have these two products in the market now and what the vision is for bringing all these together. So, essentially what we're working on here is the next generation of CAD. That's what we're so excited about. Essentially, with generative design, you have the promise of being able to do design automation. And that's a very disruptive thought. If you think of the way that we typically design, it's manually modeling things. But now we're turning more and more of that over to a machine, AI, and various types of algorithms. So how do we bring the human into the loop on that? Because we don't want a world where everything is automated. We want a world where we are driving that process. And for us, that's very much around interactivity. So what I'm going to talk about today is how to make generative design interactive. It's a new paradigm of designing, and we're just scraping the surface. So we're really pumped up to show this to you. And I'll try to get through these slides pretty fast so that Kevin can start showing it off. A little bit about us. Yeah, we're in Boulder, Colorado. We're funded by a wonderful angel investor and also Next47. And we have a patented technology which is called TrueSOLID, and that's our generative design engine. TrueSOLID is, at the heart of it, an implicit modeling kernel, which you've heard a little bit about today. And we definitely have some nice IP around that. Generate is our point solution product, and that's like our sandbox for experimenting with how to change the way we design things with generative design. It's built on TrueSOLID, and we just kind of differentiate between these two brands so that we can keep some sanity as we move forward here with the different technologies. But what we're really after here is not just making it interactive for the sake of entertainment and playing with the design while it's being generated, but making it functional. And that's why we've created our own geometry kernel and generative design engine, TrueSOLID. The output from TrueSOLID is 100% manufacturable, whether you're using a 3D printer or if you're going to go and cast the part or mill the part. And we have constraints for all of those. So we're not just going to be showing you additive manufactured parts today. We're going to show generative design for milled parts, cast parts, and additive as well. So I think you'll see with this wrench design here, it'd be very difficult to model that with traditional surface-based geometry. So the idea here with making it interactive and using this new geometric representation is that you get a functional part right away, and it's your design process. It's not just automated. And you can make amazing things like, for instance, this heat exchanger here. One of our larger customers in aerospace, who I can't name, sorry, I've got to go back one, is doing some really fantastic work with these types of complex structures that have unique performance capabilities that are just scratching the surface on. It's a multi-physics system, so we do simulation too. It's all multi-threaded on CPU and GPU. And it's for that, giving you this more interactive and real-time experience. So just a little bit about what's so different about traditional 30-year-old CAD geometry kernels, which are surface-based, and TrueSOLID. If you are using traditional CAD, you know you have to select edges to blend between geometries. But that doesn't work when you have thousands of lattices or struts or complex structures like this gyroid from the last slide. It just breaks down because you can't go in and manually select all of those. It just wouldn't work. So with TrueSOLID, you can apply blending between volumes without selecting them. additionally, in the current kind of state of the art right now, if you use traditional CAD, you're going to get these seams here, which would have to be blended if you want to get stress risers out of the part. Whereas in TrueSOLID, all that blending is just a parameter which you have total control over of. So in a new way, it is parametric, but what we would just call functional design. So it is functionally parametric. You specify functions by parameters, and you get the design that it is providing for you. We're all familiar with topology optimization. There's so much debate about what's generative design. Is generative design have to be on the cloud? Absolutely not. That's our position. So does generative design have to be on a local computer? Absolutely not. You could run it on the cloud. The reason for choosing one or the others is not really our debate. What we are saying is we just want to leverage all the computing power we have and use it for the best purpose possible. So the design on the left is what you would traditionally associate topology optimization with, which is a really excellent part of generative design. Except that if you're a designer and you make a change to this or move the cylinder or make it bigger, you would have to then go and use this template it gives you to redo all the modeling. In our system, you don't have to do that. If any of this changes parametrically or the physical requirements change functionally, it all just updates for you interactively. And this is just a snapshot of our interface here. We'll get into more detail about it, but it takes CAD files from most of the major vendors. We license Hoops Exchange to be interoperable, so thank you to the folks at Siemens Components for that. And with assemblies, you can apply loads directly to the various assembly parts and constrain certain areas, whether it's faces or parts, and it will automatically start growing the geometry for you once your functional requirements are all specified. And you can make some fantastic variations on these designs with your own control over it interactively. So you can make your own judgments and values based off the experimentation that you're doing with the design without needing to have a large automated process running it for you. So here, this is unconstrained and good for certain additive manufacturing processes, maybe DMLS. Here we have something that could be water jet. And again, this is not modeled. It's 100% automated. Here would be something that could be good for casting or perhaps even a fused deposition approach. And again, we can fill these with lattices for further lightweighting, gyroids, et cetera. We have a lot of variety on those types of technologies. So when someone might say they're the only one doing this type of technology, I assure you there are options out there. And what you'll see, I think, more of in our industry right now is more ways to design and work with such complexity. And that's a challenge we have as an industry, one we're really looking to solve and make easy to use for you. So with all that said, I'm going to toss the ball over to Kevin, and we're going to kind of get a demonstration here. I'll just note that it's generally available right now, and we've been in a beta for a period of time, but it is generally available. And with that said, please stop by our booth 2 after the demo, and we can show you some more.
All right, thanks, Jesse. So what I'll do is I'm going to go through a fairly quick demonstration. This is actually the first public demonstration of Generate for desktop. We've shown a few select people over the preceding weeks, and if you've stopped by our booth today, you've seen it. But we're excited to be here today to kind of show everyone publicly what we've been working on for the last couple of months. So I'm going to start with a pretty simple setup. I've already got a few things constrained. We're going to do a few things first. First, we're going to create interactions. So you can see as part of generative design, as we want to preserve certain bits of material. So in this case, I might want to preserve these holes within the part. So in other words, if I have some pins passing through there and I hide those pins, what's left behind is sort of these little collets. So these are the bodies. This is sort of like my starting geometry. Now I need to fill in and connect these based on the loading conditions. So we'll show those again. And then we're just going to go in and add a simple force, complete the load case here. So we're going to pick a direction vector, in this case, that edge, apply a load, start load case. And then as Jesse pointed out, one of the key things about Generate is this notion that it's interactive. So what we mean by that is, as opposed to the cloud solution that we have currently, which is great, this one allows you to see your results forming in near real time. Now, I'm using a laptop here with a sort of a medium level CPU and graphics card, but imagine using this on a really high horsepower CPU, high-end machine, and you'll see these updates. You can kind of tell it's running right now, and this is not the video, this is actually us just processing. In this example, we've got no design constraints, all right? We've just let it sort of be free. This is what we would call our sort of like, designing for additive manufacturing. So if you're gonna do a powder-based metal printer, you're not worried about supports, something like this would work really well. If we wanted to, we could also view our stress at any time. So we have this continually updating stress plot. We could view our displacement. So if we wanted to see, this is a good sanity check to make sure that you've got your load case set up properly. So you can kind of make sure that, yes, that's the direction vector that I wanted. I would expect that sort of motion. It's obviously sort of exaggerated here. And then we can go back and start considering making some design changes. So for example, one design change might be, I might want to move this pin. I might want to experiment a little bit. Now, traditionally you would think, okay, I might have to go back to CAD, transform that body, export it, re-import it. But we're gonna allow you to move components around to do design studies. So if I wanted to just move this pin up about 2 inches, I could either key in a value, or in this case, just drag it up. And the system says, hey, I have new conditions. I need to regenerate. And so off it goes, and it starts to solve again. You don't have to wait. You can keep going. You can make other design changes. You can say, okay, well, I want to take a look and see what it looks like if I was to add, in this case, an extrusion constraint. So as Jesse was talking about earlier, you saw some examples. If we were to apply what we call like a monodirectional extrusion, this would be great if you're trying to minimize support structures. So now again, it starts over, obviously has to use those bits of preserved material around the hole locations, and then it starts to solve within that, but you see one big difference is it's flat on the bottom. So we're trying to minimize, if not completely prevent, any kind of overhangs. So this will run for, again, another few seconds. At any time, we can get an update on what our mass is relative to what we started with. So in this case, we've reduced the mass by 75%. All right, and then we could try other other design constraints. We'll do the same extrusion constraint, but this time we'll do what we call a bidirectional constraint. So if you remember from one of the slides, it had sort of a water jet type profile, a 2D profile. We can do that as well. All right, so it'll delete this extrusion constraint or the previous example and start to regenerate using that extrusion. And then, really the key thing is we can move parts around, we can change parameters, we can change materials, change the forces and load cases, all kind of in real time, and you get those updates. You can also do things like symmetry, obviously, your angular symmetry, planar symmetry as well. But this is what we feel is, going to really be what changes the game in terms of design, because you want to be thinking about how you're going to manufacture parts. So imagine now another release from now or 2 releases from now where you're able to actually not just dictate a constraint for the manufacturing type, but maybe the type of machine you're going to use. Getting into specifics, pulling a list of libraries from the printers that you're going to use and knowing what their build process is. So this is just an example of a 2.5D style profile. Any other comments before I roll into TrueSOLID?
No, I think let's just show the draft constraint. So we want to show one more constraint, which is a little bit, how do I put it? Very exciting for us because it automatically makes the part draft castable. So what you'll see is a automatically generated parting line. It takes a little bit of time to process because if you imagine these algorithms are figuring out how to make it manufacturable for you, it's an exciting use of it, but it takes a little bit more time to process. So I'll just talk a little bit about the vision of it as we're going forward. Really, we see this right now being useful for all manufacturers, especially if you're thinking about 3D printing fixturing and tools. Some of the constraints we showed you had the ability to do, oh yeah, it's starting to generate now, but here you can start to see the parting line emerging on the design right here, and the 15-degree or so draft was applied. So as the geometry updates, it'll converge to a manufacturable cast part. But the idea here is that we want to allow you, like Kevin was saying, to have your variety of machines at your shop all be part of the catalog of constraints at your fingertips. And you can kind of customize the software accordingly. So with that said, we're going to also show you a little bit more about what's coming up next. And to that, we're going to open up our developer interface and bring that design in. So.
All right, so as Jesse said, this is our developer interface, but this is also kind of like a playground or sandbox where a lot of our technology lives before it sees the light of day. And so one of the cool things about it is it allows us to leverage all of the very cool mesostructures that are part of the TrueSOLID API. So in this case, I can apply a gyroid pattern, gyroid structure, to just the generative geometry. And the important things to point out here are things like the blending of this gyroid structure back into sort of that regular prismatic geometry. So you can see how we have full control over that blending. We can change it, we can make it larger, make it smaller, and that's really sort of the power of TrueSOLID modeling. One other thing that I think is really cool and that we found a lot of applications for with things like shoe wear or footwear insoles for shoes would be modifying the density of the lattice or gyroid structure based on pressures or based on stress values. So in this case, if we take a look, we've got some stresses here in the part, some strain rather, right at the top. So the red areas are areas of highest strain. And what we might want to do is inform the geometry to thicken that up. So in those areas of high strain, let's use that to thicken that up. So in this case, I'm going to set my deformation back. I'm going to turn the colors off for a second. And then all we got to do is save out that stress plot as a distribution field, or thickness field we call it, and load it back in. And once we apply that, we can then dictate and say, okay, at areas where the stresses are lowest, will be relatively thin, and areas where the stresses are high, make it a little thicker. And so what you'll see here when it's done rendering is you've got sort of thicker geometry here, and it kind of helps to overlay the color on it. And you can see that very clearly down here at the bottom too. So you've got areas where the infill is a little bit thicker. Almost, you can even make it go to the point of being solid. You can fade that in. And we found a lot of utility for this sort of variation of the lattice densities and patterns.
And these lattices can be internal shelled structures, or they can be open in certain areas. You'll have full design control over working with what we call TrueSOLIDs. So at the heart of our company, we are working on this interactive generative design for manufacturability. To close the loop on this, we'll just show you how easy it is to slice from volume data directly, where you don't even have to have an STL at this point. We have numerous relationships we're working on right now to really streamline the process of getting the data from the software to the machine that you're using, to your CAM. And this will be the same for milled parts, additive manufactured parts, et cetera, as we move forward. So I guess just to close things up, we really are just showing the beginnings of this. We have the ability also to do full-scale assemblies, so you can do multiple parts at the same time. And we'd love to demonstrate some of that to you at the booth as well. They run a lot longer. They take a lot more time. So we chose to just focus on one part. But we see this future that we hope we are pioneering, all about putting the designer in the driver's seat for generative design and not turning it over to an automated process where you sit back or go get a coffee. So we want to keep the designer front and center in this new age of designing with generative design. So thank you very much for having us. It's great to be back here again. Thank you.